let's look at section 1.3, multiply and divide monomials. We're still in unit 1 where our essential question is why is it helpful to write numbers in different ways? And we've learned to write numbers using exponents and to evaluate them, and we've also learned to change numbers from decimals to fractions and fractions to decimals. Today we're going to do something we've been doing all year long in our math minutes, and that is multiplying and dividing monomials. So with the product of powers, to multiply powers with the same base, this is going to be familiar to you, we add their exponents. So 2 to the 4th times 2 to the 3rd, they have the same base. The base is 2. So the base stays the same, and we add the exponent. So it will be 2 to the 7th power. Now, we're multiplying and dividing monomials, so we need to talk about a monomial. A monomial is a number, a variable, or a product of a number and one or more variables. You can use the laws of exponents to simplify monomials. What we've been doing in our math minutes is using the laws of exponents. And the laws of exponents are just when the bases are the same and you're multiplying, you add the exponents. That's the first one. So 3 to the 2nd times 3 to the 4th is 3 to the 2 plus 4, 3 to the 6th. Now remember that 3 is the base, and the base is going to stay the same. We don't multiply the bases. Another way to show it, to make this make a little bit more sense, is 3 to the 2nd is 3 times 3. And 3 to the 4th is 3 times 3 times 3 times 3. And so when you look at those, you've got 2 3's here and 4 3's here. So when you add those all together, you get 3 to the 6th. That might help you to understand why we don't multiply the bases. Basically, all it's telling us is that we have 6 3's that we're multiplying together. Let's look at some examples. Number 1 says 5 to the 2nd power times 5. Now, one thing that we haven't talked much about is that when you have a 5 alone, or any number alone, or variable alone, the exponent is assumed to be 1. So we'll just write that in there to remind us. So we have 5 to the 2 plus 1 power equals 5 to the 3rd. Number 2, c to the 3rd times c to the 5th is c to the 3 plus 5, which is c to the 8th. Now, number 3 is going to be a little bit different because you might notice that we have coefficients here. We've talked about coefficients before. So we have coefficients -3 and 4. So the first thing we're going to do is take those coefficients out. And then we're going to take our base. Remember, our base here is x. So our x is going to stay the same. So we have coefficients -3, +4. We have a base of x. So we're going to take those out. We're going to add our exponents, 2 plus 5. So we multiply the coefficients here because these are not the base. These are different numbers. The base is x, so we're going to multiply these two numbers and get -12, and then x to the 7th power. All right, let's look at the next page. There are some practice problems for you. Take a minute, pause the video, work the practice problems, and then come back to finish the lesson. Okay, you've had some time to finish those problems, so let's look at the quotient of powers. Well, let's go back first of all to that first page and highlight product of powers. That's our first law of exponents. And then our second law of exponents is quotient of powers. And then our next lesson will continue with some other laws of exponents, but for now we'll just do these two. So the quotient of powers says to divide powers with the same base. This is familiar again. We're going to subtract their exponents. So let's look at some examples. 4 to the 8th divided by 4 to the 2nd. Now we know that the base here is 4, so 4 remains the same. 4 to the 8 minus 2 equals 4 to the 6th. Another way to show it is 4 times 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 4. There are 8 4s. And then we have 2 4s in the denominator. And what we do is we cross off the ones that we have in common. And that leaves us with 1, 2, 3, 4, 5, 6 4s. So 4 to the 6th power. Now you don't need to do this. This is just a picture to kind of show you how this works. All you need to know is that if you subtract the 2, you're going to get the correct answer when you leave the base the same. Number 2, n to the 5th divided by n to the 4th is going to be n to the 5 minus 4, or n to the 1st. But remember that we don't need the 1, so our answer would actually just be n. Now number 3 looks a little bit harder, but it's really not. We just happen to have 3 bases here. So we have base of 2, a base of 3, and a base of 5. So what we'll do is we'll take 2 to the 5 minus 2. So we have 5 here and 2 here. Times 3 to the 5 minus 4. 5 in the numerator, 4 in the denominator. Times 5 to the 2 minus 1. Don't forget that assumed 1 over here. There's not a 1 there, but when it's by itself, we have an assumed 1. And then when we work it out, we're going to get 2 to the 3rd times 3 to the 1st, and so I don't need the 1, times 5 to the 1st. And again, I don't need the 1. So my answer would be 2 to the 3rd times 3 times 5. Take a few minutes, review through your notes, and then work the 3 practice problems down at the bottom. When you finish, bring your notes to class tomorrow, and we will go through the answers and make sure that you understand the concepts before we work on the homework together.